question, you have to solve a vector equation. Basically, they have given that this vector equation, the one vector equation here, this one, and they will ask you to find this vector v. They ask you to find for vector v because usually you done in your A levels and our O levels we solve for the scalars, but here you have to solve for this vector v. And they asked us to use this dot product, and cost product operations when we solving our solution. Straight away, if you write this equation, I already solved that, but I just describe you the approach, and then I will go through the solution process. How you do it, if assigned some kind of problem will come in your quiz. So then, one thing you can write first. I write my vector equation like this, right? This is the equation they have been given. So first, you can only use this vector dot product and vector cross product. That's all going to be used because you only have one equation. So straight away, what I'm going to do, I'm going to use this dot product first. Because if you see this one is perpendicular to both V and A, right? Because this part is perpendicular to both V and A. If I use the dot product, what will happen? Anything get dot product by A or V with this got cancelled off to V0 vector. So that's my first issue. It means if I take this equation, let's say this one, dot, let's say A, then I can get alpha V dot A plus V cross A dot A equals B dot A. Then what will happen? This part get cancelled off to 0 because these two vectors are perpendicular, right? So these two vectors are perpendicular. Due to this reason, I first use this one. And then somebody can argue why you cannot dot product or cross product by V, vector V. Why don't you choose vector V? The answer is, if you use vector V, what would happen? V dot V become V squared, and other terms come V dot V, and these two terms are unnecessary. So you don't need to do that because if you need to solve for V, you need to reduce the term that V is appearing. So simply, these operations will increase the complexity. And the other thing is, using this equation, right? This is the way how you need to think. You can write V cross A equals B minus alpha V. And also, if you get 1 and its cross product by A, you would get alpha times V cross A plus V cross A equals B cross A. Now, you can clearly see, you can substitute this from this, and also you can expand this using this formula. V dot A times A minus A dot A times V. And you can straight away see, using this equation, you can substitute to here because this part gets zeroed out. So V dot A you have here, and V dot A you have here. You can substitute this one you as V dot A divided by alpha. And then you can solve for V. So that's the basic intuition, right? And I will show how you do that one because I already did that one just a short while ago. First, you will start from here. This is the basic equation you get. Then you get the dot product with respect to A, this one, right? Straight away you can see this part goes to 0. And then you can end up with this equation. And this equation, you can write V dot A in terms of B and A, which is a constant. And then what would happen? I will number this equation as 2, and then I take 1 and cross product with the vector A. Because I don't touch V, because if we get V, the terms with V appear in this right-hand side, so I don't use V for this one, for now. And then if I got this one, and I see V cross A got appearing here, and also this is the vector triple product, and this is just a constant, it doesn't matter. Then I see V is appearing in two places, one in here and one in here. So in order to simplify this, I see V cross A, I can express it with this, like in this way, where V, the vector V is clearly separated. Because if you need to find V, you need to isolate V. So then, using this one, I substitute V cross A for, instead of V cross A, I substitute from this one, and I expand this one using the vector triple product, like in this way. And then, using 2, it means using this equation, I can substitute for this V dot A, and I can get this one. And also, I can simply reduce this one as it is. And then, if you substitute this one, and if you move all this vector V part to this side, and if you solve for V, you will get this equation, because straight from here, it is nothing much, it is just algebra. You can just solve for this one. Did you get it, or is there a problem with that one? How are you going to solve that? It's basically, you use dot product and cross product. I just basically do, I get the whole equation, and I get the constant, the vector A, and I get the dot product, and I get the cross product, and then I substitute using the equation. That's all I did. Is that a question? You can just ask around, or otherwise, I can just move in the WhatsApp chat. Also, you can tell. So, what is the problem? Is there any question or anything related to that? So, I'm going to discuss another question like this for just the sake of easiness, because it's another question that's shared by one of your colleagues. Is there a question? Or I think I have a lot of chat here. Yeah, I'm also recording. I also think the YouTube live is recording, so there's so people can watch via that one as well. So if that is clear, or do you need to any sort of like doubts or anything to, let's say, with respect to this one? So how you gonna do this one, or why you do this one? So how you gonna solve this? And is there any like kind of confusion or anything? Just let me know. And the next thing is the same thing, and there's, because this also one of the questions from your tube. So you have given two equations, and they're going to ask to solve for V, right? So in this case, also you have two equations. One is this one, and one is this one. So here, what I did was, first, I get this first equation, and I cannot get the dot product because there's not vector, because in here this is quite different, because in here you can clearly see in this equation you only have vector A, vector B, and vector V. And the second equation you have vector C, vector V, and vector S. And you can clearly see these two vectors are not included in the first equation. So in here, we have to solve for V, and we need to isolate vector V. So isolate one vector from a cross product is the easiest way to consider the triple product. If I can get something like this, A cross V cross something, or cross something in either way, either this side or this side, I can express this as a triple product. Because I know if I use a triple product, I get some sort of dot product, and I can isolate the vectors within this bracket. So with this intuition, I get the cross product with the vector C, because this is the one they have given me here. So if I expand my vector triple product like this, in this way, I can get A dot C, it's a constant, but the most importantly, in the second term, I can get C dot V. Here, they have given us the answer. So I can straight away substitute this one to here and this one, and I can straight away get the answer like this. Is it clear or? Ah, yeah, S is a scale. Okay, sorry. S is a scale. Sorry about that. Okay. So S is a scalar. So C dot V. So here, this is S. So you can substitute. This should be S. And this should be the answer, right? Again, what is you have to do is you have to think a way to make this term inside this one, and then you can substitute that one. Yeah, S is scalar. So sorry, my bad. I think the problem is I also solved with the put in the chat as well. Where's that one? Yeah, yeah. S is a scalar. Sorry about that one. So S is a scalar. So I just put up a vector, but it doesn't matter. But you can just straight away get the answer, right? So the operation is clear. So yeah. So the second one, I found some questions here. Not this one. And yeah, here. So wait a minute. Okay. So in this case, I'm gonna describe in this quiz, I'm gonna describe because I found out a very nice question here, the tan x one, right? So yeah, because I think you don't have function, so then I'm gonna describe this tan x thing. And I think I found out some vector functions over here, or else I can straight away going into this one. So this is so I will discuss the question number 10 because you have discussed the planes and the vectors, and you need to identify how you write the equation of a plane and how you write the vector of a line, and do some manipulation based on that one. Okay, so I think these two are clear. If not, just let me know. Okay, so this is the one that I draw for you guys a short while ago. Okay, so here they ask unit vector along the line of intersection of the planes. We have given two planes. I will just note it down. 2y plus 5c equal 9. And the other one is 5x minus 2y plus 7c equals 21. And they ask the unit vector along the line of intersection of the plane. Okay. So, yeah. So, and I just not going to explain the theory here. I just give you some sort of a short note here. If you get a plane, right? If you get a plane, you can use this as a short note as well for your quizzes. No proof, just the thing. If it is the plane, if you need to parameter this plane, you need the normal vector to this plane. And then you can write the equation r equals r minus r naught dot n equals 0, or you can equal write r times n equals r naught n, right? So this r naught is some point on this plane. It can be any arbitrary point. The important thing is this part. Let's assume your r is the position vector of any ordinary point on your plane. So this can be any ordinary point. And let your normal vector is nx, ny, and nz. And equal, this term is r naught, this is a constant because normal vector is a constant and your position of your plane is a constant. You can pick any arbitrary point. And then this will become nx x plus ny y plus nz times c equals r naught times n. Right? This is a constant. Important note, this time is a constant. And I write the first equation here. X plus 2y plus 5c equals 9. And this part is correspond to this, and this 5 is correspond to this, 2 is correspond to this, and it is 1 here. It is correspond to this one. Right? Basically, you can get the normal vector in this way. Right? You can get the normal vector first. Write a simple vector. I will write in red color. 1, just get the coefficient of your x, y, z of a plane equation. 1, 2, 5, like in this way, and divide it by square root 1 square plus 2 square plus 5 square. Simply the sum of the squares, right? And this itself gives the normal vector to this plane. Same goes with this one. If you need to write this one, the normal vector would be 5 minus 2, 7, and divided by 5 squared minus 2 squared plus 7 squared. Is that clear? It's a very shortcut way. You don't have to worry about anything. Is that clear how you get the normal vector from the equation of a plane? Because that's the thing that I need to highlight from here, and then I see how you're gonna solve for this one. Because that's the basic idea, because you guys always confusing. So you can forget about all these. The everything is that you have to remember, if you get ax plus by plus cz equals d, this kind of equation of a plane, you're writing this format, and you can get the normal vector is a, b, c, and you have to divide it by a squared plus b squared plus c squared. So this is your normal vector. Straight away you can write. So keep it as a short note. It's a kind of, I say, bit smart trick. But here it is asking kind of this way. Let's assume you have two planes. My drawing is terrible. I know it. You have two planes, and you need to find the intersection of this, the line of intersection of these two planes, right? So one equation is x plus 2y plus 5c equal 9. And then you can take 5x minus 2y plus 7c equals 21. Right? Now, assume you got any arbitrary point on this plane called x, y, z, on this intersection of line. That point should satisfy this equation and this equation both. It means if you can solve these two, as simultaneous equations, you can get the equation of this line. But the problem is there are 3 variables, but 2 equations. Right? Usually what we do is, in these situations, we have 3 variables, basically 3 coordinates. You can put either x, y, or z as some parameter t. Basically, what I do, I let z equals t. T is a parameter. Then I can get x plus 2y equals 9 equals 5t, and then I can take 5x minus 2y equals 21 minus 7t, and then I can have 2 equations which I can solve for x and y with respect to t. Is it clear or not clear? Do I need to explain it again? Aya, can you send the question to the group? Yeah, it is the PDF of quiz 1, and the question is number 10. Right? So here. So if you're going to solve this one, I'm going to, because in here you would get an equation of a line, and I will solve that one because otherwise you cannot tell. Like avoid, sometimes my algebraic can be messy, and I can make some mistake with solving, but the idea is clear, right? Yeah, so then I copy these equations and go to the next page and see how you can get a unit normal vector along this line, right? Because that's what it's asking. Yeah, because this question you can, this will cover the equation of a line as well as one question. And yeah, so here, what I did was very simple. I have ax plus by plus cz equals d, this kind of two equation of a planes, and I have to find the intersection of a line. Then what do we have to do? Pick one of x, y, or z, one of the parameters, one of the coordinates, and let it be a parameter called t. And then solve for the other two and make up two simultaneous equations. Here, I can take, I will subtract 5 times 1 from 2, then I will have minus 2y minus 10y equals, I would get 21 minus 7t minus 45 plus 25t. Then I would have 12 minus 12y is equivalent to minus 24. Okay, minus 24. This one is plus 18t. So divide by 6, I would get minus 2y equals minus 4 plus 3t, and then you would get y equals 3 over 2t minus plus, sorry, not plus, yeah, plus 2, right? So this is your y, and then you can get your x as, I would get from 1, x plus 2 times, this means minus 3 over 2t plus 2 equals 9 over 5t, and you would get x equals x minus 3t plus 4 equals 9 over 9 minus 5t, and then x equals, it is from here, you would get 5 minus 2t. And then you can write your x, y, z vector, any arbitrary vector on your straight line as 5 minus 2t, and your y is 2 minus 3 over 2t times t. And then you can write this as 5, 2, I separate t, 0, minus t times 2, 3 over 2, minus 1. So this is the vector along your line. Because you can write any line, equation of a line, you can write some arbitrary point on the line, you can pick any point, times some parameter, times some vector, I would say Rx, Ry, Rz. This is a vector along your line. You can write any equation of a line using one point on the line and a minus or plus parameter, a real parameter, times a vector along your line, basically a parallel vector to the line, right? Basically, this is the vector parallel to your line, and then you can easily get the unit vector. The question is asking to a unit vector along the line of intersection is this one. So you have to get the what you call the right answer. I think the answer would be around, I think, the first answer. The answer is the correct answer, but the way of solving is this one. Okay, so sorry about that one. Okay, So is this clear? Or if you have any question, you can ask. Basically, I cannot see the chat, unfortunately. Oh, I think I can join my other device right now. So then I can see the chat from there. So then it is not disturbed for you guys. So okay. So yeah, I'm not clicking the audio. Okay. So if you can send any questions here. So I join my other device, so then I can see the chat from there. Okay. So any question about this question, or do you have anything to clarify about that one? Kind of vectors, but and then I'm gonna do this one after this one to give you some answer. If anything to clarify? If someone asks, yeah, how did you get the one before equal? That one, which one before equal? Someone's asking, yeah, how did you get that one before equal? This one, or so? What is he asking for? So someone is asking. One before equal. So actually, I don't know what is you're asking. Yeah, sometimes that you can get easily the answer by n1 cross n2. Yeah, that's also true, because if you get the plane of intersection, you get the normal vectors of this vector planes, this n1 and this, let's say this n2, and if you get n1 cross n2, and then you can also get a vector parallel to this line of intersection as well, because that cross product should go along this direction as well. So it is another way of doing it. That's also true. That this basically done laptop, because that's I need to just explain about the equation of a line, so then I can explain all of them together. You asked the last line, so to this one. So what I did was I simply substitute because here I take x, y, z to be the any coordinate of any arbitrary point on the line of intersection. So I get z as a parameter and I solve as them simultaneous equations, because if I take z as a parameter, I can take two equations for x and y using t, this parameter t, which I use to denote z as some parameter, and then I can solve for x and y with respect to t. I can get the answer from t, because it's coming from t, because there's no way that we can find some fixed coordinate, and then the answer will come with respect to t, and then you can solve for x and y, and I will get y as this and x as this. Once I get this one, because I have this is my x, this is my x, and this is my y, and I have z equals t. So I simply write my general coordinate as, instead of x, I put this one. Instead of y, I put this one. Instead of z, I put t. That's the whole thing I do. Is that clear, that I want to answer the question? Because they ask. Okay, so someone is asking, they're only asking the straight line. So I think should be informed that earlier. Okay, so okay, so okay. So line, I will give a quick revision for you guys then. So I think this is clear. I think that's fine. For the line, let's say you have any arbitrary point of line, you have three forms of equations, right? let's say you know one point on this line as A, B, C, and this is a point on the line. And you know a vector parallel to this line as, let's say, P, Q, R. Then you can write the equation of this line as A, B, C plus lambda times P, Q, R, where this lambda is a parameter. Right? That is one way of doing it. So this is actually form of the line. Basically, this something like y equals mx plus c, because this is equivalent to your tangent in your straight line, and this is kind of the intersection. It is not exact that is how you're gonna do it. So if you have any lines, if you get any equation of a line, you have to find, you can easily, if you write in this form, you can, using this, you can find the direction of the line. If you get this quantity, this one, if you get this one, this is actually unit vector parallel to your line. Okay, so if this is the case, let's say you need to find an angle between two lines. That is actually one question that they're going to ask you. So you have, let's say this is one line. I would say this line is equal to some point, let's say R1 plus lambda times, let's say V1. And this is equation would be R2 minus lambda times V2. So once you write your equation in this form, using this one and this one, you can find the unit vectors parallel to this line. Once you get the unit vectors, let's say they are U1 and U2, and then you can get this angle theta by cos inverse U1 dot U2. So if you are only getting the equation of a lines, what you have to do is you have to write your equation in this form. Some constant vector times some parameter times times another vector. So then you can get this one as a vector parallel to your line, and then you can find the angle. So anything in that. Is that clear? So if you have any questions into lines, just to put to the group so that I can discuss. So I think they will give you some sort of planes, because if you do did you do them, because in the group they have mentioned that you don't get planes for the quizzes, but they have do those stuff in the lectures. If they do, they can ask. But if they tell that if those don't come, so they don't gonna ask. But that's the thing that you're gonna mention. And other thing they're gonna ask from the lines is something like this one. So let's say you give two lines. Let's say this is R1 times lambda V1, and this is let's say lambda 1, and this R2 times lambda 2 V2. And they're going to ask what is the distance between these two lines. Let's say this is a perpendicular vector. So let's say V1 equals V2, or kind of this, right? So these two vectors are perpendicular. So how are you going to find the perpendicular distance between those two lines? That's the, I would say, that's the hardest part that you're going to encounter, right? So to do that one, you need to get the distance between those two. You need to find some point on this line. So easily you can get this R1 is on a line, because you know R1 is gonna position vector is on this line, and then you're gonna find the point correspond to the other end of this tangent line on the other line. Right? Let's say this is your point P1, and you're gonna find the coordinate P2, which is the other end of this perpendicular line. To do that one, you have to, or else what you can do is this way. That's the basic thing that you can do. you can get any of the root. Let's say this P1. You can easily get from this, let's say this point correspond to R1. And you can get another P2. Let's say this a point correspond to R2, right? So then, if you draw this line, you can get the distance of this line by easily using, because if you know R1 and R2, you can get the vector R1 minus R2. Let's say this is some as, let's say, some, let's say, how would I normalize? I would say some sort of M1, M2, and M3, let's say. And you can easily get this distance D, let's say P1, P2 distance D, you can get square root M1 squared plus M2 squared plus M3 squared. You can just get in this distance. But you have to find this angle, right? Easily, you can find the equation of this line because you know this vector. And you know vector parallel to this one, you can get R1 minus R2 dot V. And you can divide this guy by R1 minus R2's norm times V1's absolute value. And this is equivalent to the cos theta value. This is theta, right? So then once you find this angle theta, this acute angle theta, you know this distance. You can get this perpendicular distance. Let's say this is T. T equals D sine theta. Okay. So this, I think, the most two questions that you're going to ask from the, if you are only getting the lines, those are the two questions they're going to ask for. I think one is they're going to ask the angle between the lines, and the other thing they're going to ask, they have give you two parallel lines, and they're going to ask what is the distance between those two lines. So that is how we're going to do it. Okay. So then I will gonna display. I think I show some questions regarding the tetrahedron thing. I think they find the areas, but I'm not sure whether that is. So, give me a minute. Yeah. So if there are any question, you can just let me know. No, not here. Yeah, this is actually the, you know the meaning of direction cosines? You know the direction cosines, or do I need to explain it again? Explain it, direction cosines. Otherwise, you will find struggles to do that one. So direction cosine is nothing but, let's say you have a vector. They ask, let's say x, y, z. Direction cosines are this quantity. It's basically the direction cosines are, once you normalize this vector to a unit vector, simply these coordinates, right? Nothing more than that. Okay. So these are your direction cosine. Direction cosine is basically, once you get the unit vector out of any vector given, simply the coordinates correspond to x, y, z axis, right? So that's do not get confused to that one. These are called direction cosines. Sometimes they're gonna give you a vector and they ask what are the direction cosine correspond to x-axis. Then you have to just write this one, or if we ask to y-axis, you have to write this one. And I'm gonna find, I saw a problem with respect to the tetrahedron. Find the angle. I'm just yeah. So this is the one. I will gonna do this question because it is, I think, quite new. Not quite new. It is quite different. This is one of your older tutors. I will write down the question. They're going to ask to find the distance between these perpendicular two lines, right? That plus 2 divided by 3 and x plus 1 divided by 1, y plus 2 divided by 4 plus z minus 1 divided by minus 3. And remember, this is another way of expressing equation of lines, right? Don't confuse if you get this one. All you have to do is, you have to write like this way. This very basic thing, I think, if you have encountered, say, equate this to some sort of kind lambda, then you can write x equals 2 plus 4 lambda and y equals 7 minus 4 lambda and z equals minus 2 plus 3 lambda. You just have to consider this equation, and this equation. Then you can write your any arbitrary point on your line like this way, equal 2 plus 4 lambda, 7 minus 4 lambda, minus 2 plus 3 lambda. And then write the constant only, plus lambda, and you can write 4 minus 4, 3. And once you write this one, this is the exact same format I discussed you previous. So this is nothing different. If you give a line in this format, write down these equations and convert it to the format you desire. The format is very easy to handle. This is a line parallel or vector parallel to your line, and this is a point on the line. And basically, if you, in a shortcut, you can easily write in this way in a single shot, write in this way. You can write, I write in this way. Let's say I consider the first equation, the one here, right? One here. I can straight away write x, y, z, a shortcut, right? Because you have MCQs. The first one is the negative of this one. This is 2. And negative of this one. And the negative of this one. Right? Plus lambda times, and the vector would be exact coefficient of this one, and this one. So you don't have to go all of these steps. Straight away, if you see that one, get the negative coefficient of this one. It is the point on your line, and straight away write this coefficient in this one and put some parameter lambda, and boom, you get the line. Is it clear, or you have to clarify that out? Because that's a very shortcut, right? Do I need to explain it again? Because you don't need to perform all of these steps. Once you see this one, you can straight away write in this way. So then, if you need to get the distance, you straight away you have the 2 points on the line, and you can perform this operation I mentioned before. Do you need to solve it with you, or I think if you have any question, just let me know and don't stay silent. And if you have anything to ask, just ask. And if you have any confusion, anyone? Hello? Is it fine? And I can write the other equation. I will write the equation straight away. Like this, I just copy this one. And because I'm guessing we have MCQs, and don't tell that you have essay questions here, and then it's going to be not a problem and difficult for you if you need to have to write the stuff. So if you get this way, because I have to find the distance between these two lines, right? It's a question from our tutorial. I think it is actually the tutorial 4, I think 2020 batch. The one of the guys who have sent to me. And then write your first line. You can write straight away 2, 7 minus 2 times lambda times 4 minus 4, 3. And your line 2, you can write minus 1 minus 2, 1 plus some, let's say this lambda 1, this is lambda 2 times 1, 4 minus 3. Sorry, this is 4, right? What is the distance between the lines? And this should be 4, right? Otherwise, this shouldn't be 1 because I think in the printing mistake, it is 1. Oh, my bad. I explained, I think I mistakenly put the thing on my whiteboard. Sorry for that, I think for the YouTube live guys. So yeah, this is how you're gonna use it. And then this should be 4, right? Otherwise, it is not gonna be perpendicular. And then you have 2 lines, right? This is your L1 and this is your L2. And I would say this is my P1, it's a point on a line and its coordinate is 2, 7, minus 2. And I say this is my P2 and its coordinate are, I would say, minus 1, minus 2, and 1. And I need to find the perpendicular distance between those 2 lines. Okay, so I get this distance first. Right? I get this distance first. Let's say distance P1, P2 distance. And or else I would get first, I would say this is P1, P2 vector. I would get 3 and 7 minus 2, it is 9. And this one is minus 3. And I would get P1, P2. This absolute value is square root 9 times 81 times 9. It is square root 99. It is 9 times 11. I think it is 3 times 11. This is the distance. And then I need to find this angle theta. So this theta, angle theta is equal to cos theta is going to equal, I would say 3, 9 minus 3 dot 4 minus 4, 3 divided by 3 root 11, the absolute value of this guy, times square root 16 plus 16 plus 9. So once you get that one, you can find the cos theta, you can find the theta, and then straight away you have to do the distance is gonna be, this distance gonna be 3 root 11 times sine theta. So you can straight away find that one. Yeah, I closed that. Sorry about that. So I closed that one. So the YouTube live guys, sorry for that part because I mistakenly opened the PDF on my laptop. So I know that whiteboard is closed. Sorry for that one. And yeah, is that clear? Is that clear, or do I need to explain it again? Because this one other time that you can you are gonna ask for the equation of lines. So yeah. So now I'm gonna say I see some problem. If you remember, just send me. I saw some. So in the volume of a tetrahedron problem, because it is really important. If you see something, some problem, because I saw some problem one of in your tutorials. I save it for the solely, but I cannot find the problem here. It's there. They have given you 4 coordinates of the point of a tetrahedron, and they asked to calculate the volume. So there I need to explain that problem to you, because that another thing that is they're going to ask for you to, if they are only give you the lines or the cross product or dot product, and then that's one of the very basic questions that they are going to ask you. So if you have that question with you, please send it to me, because I cannot find it that now right now. And I don't think you are going to ask for some sort of proofs regarding Supra and Infimum, so I just going to skip that. And if you have any doubt regarding Supremum or Infimum or any of the real stuff, just put in the Zoom chat or the WhatsApp chat. I will answer about that one. But I need to do that, the problem related to the tetrahedron for you guys, because I think it is a very important one and it can give you maybe a couple of questions regarding that one. So I'm still searching for that one. If you have someone have like have that equation, just send it to me. I don't know whether it is on your WhatsApp chat or one of the tutorials. Where is that one? A tetrahedron has one vector except the origin, and other words is the points. A normal vector. Okay, so somebody has give me the answer. Thank you for that. So a tetrahedron has one vertex at the origin. Okay, so you have a tetrahedron. So you have one vertex at the origin. It means 0, 0, 0, and you have other three vertices as. You have other vertices as A. You have 1, 2, 3, and B. You have 1, -1, 0, and you have C. You have 2, 3, 1. Okay, so tetrahedron is something like this. Yeah, I think it's look like a tetrahedron. How should I draw it? My drawing is not correct. Sorry for that. Okay, so that's it. So this is O, A, B, and C. Okay, so these are tetrahedron. So okay, so they're gonna ask a normal vector to the plane ABC, equation of the plane, area of the face ABC, okay, and the volume of the tetrahedron. So I'm gonna first find the volume of the tetrahedron, right? So first, consider. I'm gonna consider this the face of OAB, the way I draw it, right? So since I know the coordinate of each of these three vertices, I can straight away find the OA vector. OA vector is nothing but because 0 is 0, so then straight away I can tell it is equivalent to the vector 1, 2, 3, because this is the origin, right? And OB vector I can get 1, -1, 0. And if you need to find the area of this triangle, it's very easy to do. It is given by half of the magnitude OA vector cross product OB vector. It is very easy. If you given a triangle, if you need to find the area of it, you have to find two vectors along its two vectors of its sides, along its two sides, and then get the cross product, and the area would be half of it. Okay, now you have to find the volume of this one, right? Volume of this one. What is the? I need to find the equation. You don't need to. Yeah. So yeah. So And the volume of this tetrahedron is equivalent to V equals 1/3 times and area of this base times H. H means the perpendicular height. Okay. Yeah. So yeah, I think I need to get the verification of the minute. Okay. So I need to get this height of this H to deal with this one, right? So first of all, what you have to do is you have to find the normal vector to this plane, right? How you're going to do it, because you have this cross product, right? This cross product itself is parallel to your normal vector, and get the unit vector parallel to OA cross OB. And then you can get the normal vector along this direction, or it can be to the other side as well, but it doesn't matter. And then you have to find this height, right? So in order to do that one, you have to get either of these vectors. You have to get either AC, or you have to get BC, or you have to get OC vector. Either of these vectors you have to get. And then you have to get AC, or either of these vectors you have to get, I choose AC times this normal vector. Once you get this dot product, you will end up with this H. You have to simply select one side other than the three sides of the base, and find the vector along vector perpendicular to your base, and then get the dot product. You can easily find this distance H. And then once you find that one, because you have all the coordinate of these, and then you can find this H, B you easily find, and then you can easily get the volume, right? Okay. So, and also I'm gonna try out the second question that you just put to the group right now. But is that fine? Because I'm not gonna solve it, but the solving take too much time, but the way of solving is clear, right? So first you have to find the area of one face, and then find the normal vector to it, and then get a side of a different side from the three sides of the base that you consider, and then get the dot product between the normal vector and the one of the side you chosen, and you straight away end up with the perpendicular height you needed. Fine, or do I need to explain it again? Just let me know. Hello. And I put one of your guys as co-host, and if some of your guys have entered the waiting room, just what you say, like just enter them to the meeting. Otherwise, they will left out of the meeting, right? So because in this meeting I cannot turn off the waiting room, unfortunately. So please do, okay, because I see a lot of pop-ups coming out there. Okay. Is this clear, or you have a bit more explanation on this one? Or is it still confusing? Just tell me, because you have the quiz, not me. So then you need to ask question, because I'm get too fast, because you guys are send a lot of questions, but I need to, I think if the only lines are there, I think that's pretty much that you're going to ask for the equation of the lines. They basically ask for to find some areas, and they're going to basically ask for the difference between the parallel lines, and they're going to ask angle between the lines. And the other thing that they're going to ask, like something like this, if they give some equation of a line, r plus lambda v equals 0, something like this one, or r plus lambda v, this one, this is your line. and then they are going to give you some point, let's say point P, and they're going to ask distance from this point to your line, right? So then it's basically, it's very simple. What you have to do, because straight away, if you see this equation, you know some point on this line, let's say this point P, and you know its position vector given by vector R of this your equation, because the line of equation can be written as ABC plus lambda times some vector, right? Because this vector is along your line, and this vector, this coordinate is always beyond your line. That's for sure. Okay. So then, if you know this one, and you know because this let's say this coordinate is P naught, the coordinate of this line is given. Let's say it is x naught times y naught is z naught, and you can get this distance because you know the coordinate of this point and you know the coordinate of this point. You can easily get distance of this P naught line, right? And then if you need to find this perpendicular distance, what you have to do is you have to get a unit vector along this line and unit vector along this line, and then you can basically get the cross productive. Let's say you get vector v and divide it by its magnitude, and then it's become the unit vector parallel to the line. I called it the u, right? If you get the quantity, let's say I denote this vector as, let's say, some vector c, and if you get the quantity c cross this unit vector, and if you get the magnitude, it's equivalent to this perpendicular distance. Basically, this is equivalent to magnitude of c times magnitude of u times sine theta. Since this is 1, this is become c magnitude times sine theta. C magnitude is nothing but the length of P naught. And then basically, if this is theta, because this is theta, because you consider this vector and this vector, and then straight away you can get this perpendicular distance. Or else you can find the cos angle and then get the sine angle either. Either way is fine. Some of us can't we use straight away use the scalar triple product? Of course you can use. You can use this one as well. You can use the scalar triple product. Let's say you can use OA. Let's say in here you can use 1 3 times OA cross OB dot AC. Yeah, this also correct. This also you can use. Because this is scalar triple product, we can straight away use. But if you need to, but if you straight away going to solve this, but it is gonna too hard. But usually going to solve this, you solve this cross product first, and then get the magnitude, and then get the dot product out of that one. So we're going to straight away do that as well. That's also not fine. But if it is too confusing or it is too hard to solve, because the thing is like in these problems, it is not the time is too taken not to think. It's to solve and to just to play with the numbers and get the answer and just to get the numerical answer. That's why that you have to invest most time out of your when you're working out the problems. So there, I think if you can use the scalable product, that's also fine. But the amount of computational complexity is similar, because you have to anyway you have to implicate this cross product and you have to evaluate the product. But here the same computation, but it is more steps. But then the chance of doing a mistake is quite less, right? If you're doing in this path, what you have to do is you have to evaluate this separately and then evaluate the product separately, and then I think then you can end up with the answer. So that's also correct. This also correct, right? So this is called a scalar triple product. This also correct, but remember the factor of 1/3. Otherwise, it will not give you the correct answer. So is this correct, or is this fine, or you have to any explanation regarding that one? You can use any scalar triple product or anything, but the main thing is you have to be very careful with the MCQs, but because you have to pick the right answer. Because if it is one of your solve I would say some of your summations or some of your algebraic manipulations goes wrong, then your entire answer can go wrong. Can you describe the difference between parallel and skew lines? Okay. So yeah. So in the three-dimensional geometry, yeah, basically skew lines are like this way. Let's say you have a three-dimensional space X, Y, Z. You have two lines. Let's say one is going this way and other is going in this way. These two lines are clearly not parallel. Assume like this way. Okay. Assume like this way. I'm going to explain this one. So I'm going to explain the difference between parallel and skew lines. So let's assume you have some line in this way. And this is X equal, let's say, minus 10. And you draw another line parallel to this one. Let's say this is X equals 1. And these two lines are parallel. Then you draw another line by rotating this line, by not moving the x-axis, but along the x-axis, you rotate along the axis, not around x-axis. You rotate around x-axis, it means you rotate around the plane. These two lines are similar plane, but it is now rotated. Then these two lines, if you consider, let's say this is line 1, this is my line 2, and this is line 3. If you consider line L1 and L3, they are not intersecting each other, but they are not parallel either. So L1, L2 lines are, we call it skew lines. They are not parallel, but not intersecting. You get the difference clearly? Hello? You get the difference? Yeah. Okay. So that's the difference, right? So parallel and skew lines means basically it is only happened in the three-dimensional or three-dimensional. You cannot draw skew lines in 2D, but you can draw the skew lines in 3D geometry. Okay. So, and there's another question that I need to describe. This one. I think it's actually it's quite interesting problem for me as well. Let's see. I can solve. And then they have given a minus b dot product a plus 2p equals 4. So then they ask the value of this one. Okay. So first expand this one. So I would get expanded this one. A dot a plus 2p minus b dot a plus 2p equals 4. And you would get a square plus 2 a dot b minus a dot b plus 2b squared equal to, and then you would get a squared plus, I can write this one is a dot b plus 2b squared equal 4, and then you can write a squared, you can directly substitute this one, a squared, because they ask the value of a squared, so I keep it at this way. This can write a squared absolute rate and b space value and cos theta minus, for this one 2, I can write a squared, a absolute value divided by 2 squared equals 4. So I can write a squared square times a absolute value and a absolute value divided by 2 cos theta divided by a absolute value squared divided by 2 equals 4. Then I can have, I can take a absolute value squared out, and then I would have half minus half cos theta equals 4, right? So this is the thing that I'm gonna have. And then I can get a squared, this one, and equal to 4 divided by half minus half cos theta. So this is the thing that I'm gonna have right now, okay? So, and the question, they are telling nothing more than that one, and they can say, what is the value of A absolute value, right? So here, this thing, we know cos theta is less than equal to +1, greater than or equal to -1. And then we know minus half greater than or equal to half cos theta greater than or equal to half. And then I can write half cos theta minus greater than or equal minus half, less than or equal plus half. And then I can add 2 and over 3 over 2 greater than or equal. I can have minus half minus cos theta 1/2 equal plus half. So using this one, I can get 1 over this thing. 1 over this thing is greater than or equal 2/3 or 2. So I can get a square greater than or equal to 8, less than or equivalent to 8 over 3. So what is the answer in this range that they have given to you? Clearly it is 8 over 3 is less than 4. So basically, and we have to get this one, so we have to get the square root, and it is 2 square root 2, and this is 2 square root 2 divided by 3. So the answer would be, oh, seems like there is multiple answers, right? Square root is also there. It's interesting. Yeah, here I think because this is the range should be for A, because they have nothing more than given to this one. If A equals this one, what is the value of A? Is 4. Yeah, I can, if I can say cos theta is, if I put to 0, and I think I can get something out of that one. I think, yeah, that is the thing that I can get for. So I say it is cos theta between 0 and 1, not is going to 0, because I can always get for this one. If the acute angle, let's say, if I consider that only the acute angle only, so then here it is 0, and then this is 0, and this is 1, and this is 1 as well. So then this is 4, and if we get the square root, this is 2, and it is, then it is going to be, the answer is going to be 2, right? From these answers, I think answer is going to be 2, not 1, it is 2. This is the only answer they are given in the range is 2, because the only thing you have to do is you have to restrict the theta in between 90 and 0, because whenever we're taking the angles, we can always consider the acute angle between the lines. So then if you consider the acute angle between the lines, then you don't need to consider the cos theta being -1. So you can easily tell them that between 0 or +1. So then you can do it that way. You can just consider it, just take an assumption. Basically, that's how that you're gonna have to do, because anyway you have to take this absolute value. Right? Is that fine? But there's a problem, because if you can have something like this, now it is going to be problem, but they're going to tell that one at least like they have acute angle in between. If it is the acute angle, you can certainly have this answer as A equals 2, but otherwise there's a pretty hard answer to answer. Yeah, it is plus. Okay, so it is plus, right? So it is plus, and then yeah, it is plus anyway. My bad. So if it is plus, then I think if it is plus, I think it is going to be correct. I think. My bad. Sorry. Oh, what happened? Yeah. So if it is plus, you can get 1, 302, and then yeah, then if it is 1 over this guy is less than 1, greater than or equal 2 over 3. Yeah. So then it is gonna be, this guy is gonna change, and this is gonna be less than this one. It is 8 over 3, and this is gonna be 4. So it is greater than or equal to 2, and less than or equal to 2 root 3 over 3. This kind of thing. Right. So just so it, I think then the answer is gonna be, I think still it is gonna be 2 can be the answer. 2 can be still the 2 can be the answer because that is what they have given us. Yeah. So I think it is clear, but that's the way I would do it. Just solve it, but you can just substitute it, and then you can get the equation to this a squared using cos theta in terms of cos theta, and then you know cos theta can vary between -1 to 1 or +1 to -1, and then just get the equation. At least that they can told that it is not perpendicular, right? If it is perpendicular, it's kind of thing. So you have to just get the equation and then just solve it. Yeah. So any question apart from that one? If I put -1 here using this one, I think, let's say what will happen if I put the -1 here. If put I -1 here instead of 0, then this would become -half, and this would become half, right? The same thing will come, but it don't make much of the difference. Yeah. So it won't take much of the difference. So just take the equation. So I just leave it there. So then, because I think it is some sort of intimation, because they need to give some sort of additional detail, at least, then I will just work out the problem after the session and just put it into the book. Okay. So if any of the questions persist, and the tetrahedron problem is also there, and yeah. So is there anything that you need to ask from the either vector? So just put into the chat so then I can answer. I think then I think I can explain that answer to you guys. So because I went too fast, but still I think you get something out of it. Just any question that asked, like don't hesitate to just WhatsApp or private chat to ask, so then I can explain. Yeah, sorry about that one. I think in this year I just made this positive sign in solving, but the thing is clear. So you have to get an expression for a squared, and then you have to get some. You can end up with something like greater than or equal and less than or equal, and then see what is the answer that they are given falls within that range. If it is outside range, you can just easily you can easily verify that answer using that range. Anything that you need to ask from real analysis or something, because actually I don't know what is the thing that covered you up to now, because the most of the problem that I get related to vectors, that I explain the vectors. Otherwise, you have anything to solve, and yeah. If you have guys anything to ask, just ask. And I have to show you something if you have, because I prepared something. Do you guys have matrices to the quizzes? If you have matrices, I can some tricks to show you to how to find an inverse of a matrix using the scientific calculator. You need to show that one. Yeah, they have given us some questions. Someone sent me the question regarding the field axioms. I'm sorry about that when I'm not much remember of those stuff because I haven't touched them for a while. Yeah, I can only guess now, but I don't think give you the wrong information is the best thing to go, because honestly, like I don't have much of the familiar right now with the field axioms. So I will show you something, because I think in the quiz one, I think you have some sort of, where's that thing? The thing is, like, today kind of like bit messy because I didn't expect that amount of participation at all. So then what I have to do is like I will show you some other trick in case just to get some matrices or in the future as well, because it is useful for you, even though it is useful to when solving simultaneous equations. Yeah. So yeah, let's assume you need to find the inverse of this kind of matrix, right? Let's say you need to find the inverse of this matrix. That's a nice way that you can do from your scientific calculator. So I will show it to you right now. Oh. I will. I think I turn off the screen sharing right now. I think you can see my screen, but the problem is, so I remove the, yeah, I think you can see my scientific calculator, right? In your screen, right? How can I hold this one? Okay, yeah, this way. So first you have to do is turn on your calculator and then go to the mod like this. Clicking this way, you can go to the mod, and oh, it is flipped. Video, I have to see whether my video is correct in the, yeah, okay. So first you have to go to this mod, right? This mod, and you have to go to the matrix mod, pressing 6, and then you have to enter your matrix, and you have to pick either of these 3 matrices, and I put matrix A, and then your matrix A is 3 by 3 matrix. Then you have to enter your matrix. How you do is you just enter the number and press your this equal sign, and then you can move around using these arrow keys, right? You can move around these arrow keys, whatever. Okay, so you can move around these arrow keys, and this 0 and -1, and then you have to equal 5, 1, you have to equal 0, and then you have to equal 0 and 1, and you have to equal 3. Once you finish entering the matrix, you have to press the shift, right? Shift, and then you have to press number 4 in your calculator here, right? So once you press that one, you can see this menu, and here you have to choose 3, and then the matrix A will come up in your calculator, and you have to press this button, the button under the mod here, the X inverse button. Once you click this one, you can easily, straight away, it will give you the inverse of the matrix. So this is pretty useful when you are solving the equation. And also, if you need to solve your equations, you can go to this mod 5, because since you have what you call the MCQ exams, this is very handy. You can go to this equation mod 5, and then you can pick what is the equation mode that you need to solve, whether it's 2 variable ones or 3 variables ones, or it's a quadratic one, or even the cubic one. You can solve using this calculator. So basically, you can go to 1, and then you have to enter your A, B, C values in this format. Let's say this is equivalent to AX plus BY equals C times equals 0 equation, right? If you see the mode equation again, this is the format that they ask you to enter. So A means your coefficient of X value, B is your coefficient of Y, your second variable, and C is your constant. So you have to write in this format, put the variable in one side and the other side, and then you can, if I put the number 1, and then you have to put your coefficient, basically coefficient of your first variable, coefficient of your second variable, and the right hand side of your first equation. And you have to add, when you add those two, once you press the equal button, you can straight away get the answer to your equation. So that's basically the thing that you can do with your calculator. Because I just explained it, it is very useful if you are doing this type of question. You don't have to work out your problems by hand. You can straight away put the answers using your calculator. So I will share some video in YouTube or something for some detailed explanation, but make sure that you watch video and you get familiar with that one to solve the equation using a calculator. Yeah, so anything more than that, or anything that you need to ask from, you can just ask right now, because yeah, so if that is the case, I think we can just wind up. If there's no problem, or it's a problem that you can just put into the chat. You can put into the chat, so then I can discuss. If not, if that is the case, I can just we can just wind up. Or if you have anything to clarify with the quiz or anything you're unsure about, you can put in this chat. Or yeah, can we use FFX90 CW calculator in university? So I just need to check here. So you're asking about FX90 CW, right? Is this the calculator that you have? Is this the calculator you have? I think if it is, let's say, if it is not programmable, you can use it. Oh, what is it? If it is not programmable, you can use that one. It is non-programmable, so you can just use that one. That's fine. So the task is you can just use the calculator. So whatever the calculator you buy, it should be non-programmable calculator. So if it is non-programmable, you can just use in the university exams. But to be in the better side, ask from the university or department. Basically, you can ask from the Department of Examination, so they will tell you so what are the calculator models they are allowed, or if they are not confident about the model, you can just show them a picture or some spec sheet or something, and they will say, okay, that is allowed. And usually the condition is it should be non-programmable. Yeah, so if that is the case, I think we can end the session now. If you have any question that you can just ask me about the chat or something, I will be online around, I think around 4 to 3 hours. So then, yeah, that's almost done. Thank you for joining, and hope I think it is helpful for your quiz. Bye-bye.